So sometimes you'll just be given a graph like this, and even WebWork has a few problems like this. They give you a picture of a graph, and they say, okay, here's a transformation. Tell us which one of these graphs down here is uh, this transformation on that graph. Well, the first thing I should do before anything else is I have a parent function, but I might want to have a table of values. So I have enough points that'll tell me what the shape looks like, and I can transform using the graph transformation techniques we talked about to get the table of values I need. So I start off with this table here going, having negative 9, 0, negative 4, negative 5, 2, 1, 6, 5, and 8, 4. Those are all ordered pairs that I see by those big dots. If you wanted to have more, that's fine. There's some you'd probably take some guess at or say it's close to this. You have to be careful with that though, because along the line as you're multiplying or dividing or doing some other things, where that point ends up might look a lot different with respect to the others if you were rounding to begin with. So you don't want to guess too hard. And if they give you those nice big dots, use them. I'm going to transform these 5 points only. So look and see what I got here. I have a negative 2 and a minus 1 outside the parentheses, happening to the function. I have a plus 3 inside. So I have two vertical transformations, one horizontal transformation. So based off of those numbers, the x's I should subtract 3 from all of them. The y's I should multiply by negative 2 and then subtract 1. And that's something you should be doing when you do these type of problems is tell me what you intend to do based off the transformations. Don't just come up with a table or just, kind of draw something that looks like this shape in somewhere. You know, show me, what you're intending to do with these x and y coordinates. Show me how you're going to find the answer. Show your work. Important. So, I come up with a new table of values, and that's what the end result would look like. So the subtraction of 3 for the x's meant that I did shift left 3 units. The multiplication of negative 2 tells me that I did a vertical flip, and I also had a vertical stretch by a factor of 2. The subtracting of 1 down there also means I shifted down 1 unit. So there's a lot of things that happen here in this particular problem that I could identify from the various operations I've already defined. So you're not losing anything when they're asking, okay, is it a stretch or a compression? Is it this? Is it that? Which ways to go? Is it a shift and all that stuff? You're perfectly capable of, doing that based off of knowing what the operations are. Again, from the same parent function, starting with the same points, I have f of 2x minus 3 minus 4. I see two horizontal transformations. I see the multiplication of 2. I see a subtraction of 3. I also see the subtraction of 4 as a vertical transformation. Since I have two horizontal transformations, again, I have to make sure that I'm doing the opposite operation and then I'm also following the order of operations in reverse. So when I look at the two things I have to do in here, I see a division of 2 has to be done since it says multiply 2. And addition of 3 has to be done because I see it says subtract 3. But which order do I do them in? Well, the typical order of operations would do multiplication or division, then addition or subtraction. I'm going to have to reverse that here. So the addition of 3 that I mentioned before has to be done first, then the division of 2 comes second. Whereas the minus 4 for the y's, I'm just going to subtract 4 from my y's. There's only one operation out there. So I want to add 3, then divide by 2 for my x's, and then subtract 4 for my y's. So if I do that, that's what I get for my x and y values. I plot them and draw the graph. And always keep in mind, like as you do the parent function, make sure you know, okay, if you're doing a graph like this, keep track of which parts, are the straight parts or the pointy parts, which ones are the more rounded. I kind of keep track of that and say, well, the first 3 I come up with indicate the pointy part, and the last 2 kind of are where the rounded stuff goes. So, that's one way of trying to keep track of some things too. And because if you're drawing a graph that looks nothing like the original, then you're not doing this right. There should have some similarities, even if it gets turned upside down. That's something that's still a similarity, just oriented differently. If you're getting something that looks like a check mark with a handle at the end of it, you end up drawing something that looks like like a six pointed star, that's not what you should be getting. I mean, so